Okay, hey everybody, this is Precalc A 2-4 part 2. Pretty much needed to split this into two parts because there's a lot of material there. Hopefully the long division, synthetic division stuff went well. Now we're going to try and show why that's beneficial and how we're going to use that, and then try and do some more stuff. You'll notice that I haven't done a lot with the calculator. So far, a lot of this is non-calc and procedurally based. So let's just continued on from our other stuff. So we're going to start off with something called what the heck are rational zeros. We're going to actually do it with nothing here. So let's say that I had f of x is equal to this thing right here. And I know it's a cubic, right? So as a cubic, it could do something like this, which means it could touch potentially up to 3 different places. No more than that, but 3 different places on the x-axis. And my question is, well, what are they? How can I find out some of those things? Well, I could randomly go, I don't know, let's see, does x plus 3 work? Can I do that? Does x minus 4 work? Could I do that? Does x plus 5 work? Can I do that? And you know that if it's a remainder of 0, then you know it works, and it's one of the factors, right? And if this worked and got a remainder of 0, then it'd touch at -5. And if this worked, then it would touch at +4. And if this worked, it would touch at -3. Well, you don't have to just randomly guess. There's a rule. The rational zeros theorem says that if there are going to be factors of this thing, that they must be in the part of this ratio. It's the constant, any factors of the constant, divided by any factors of the leading coefficient. And that's got to be the highest agreed ones, whatever this is. So in this case, I know that if there's going to be something that works on this particular problem, I know that I'm dividing it by 1. Okay. So what are factors of 24? So I could have plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Now, that's a lot because that's a 24. But if this was a 7, then you just have plus or minus 1 and plus or minus 7, right? So that makes that a little bit easier. So I do have to check any of these different things. And of those things, something may or may not work, okay? So again, that's the rational zeros theorem. So let me show you one more example right down here in this little space. Let's say that I had this, f of x equals 2x squared plus 3x minus 7. Then I would have to look at these possibilities. The factors of this term, plus or minus 1 and 7, divided by the factors of the first term, plus or minus 1 and 2, which means that these are all my possibilities. I'd have plus or minus 1, 7, 1/2, and 7/2. Those are all my possibilities. So if this was to cross the x-axis in a rational place, not irrational, right? If it was to cross in a rational place, it would have to cross at one of these 8 locations. The positive of all these and the negative of all these. Okay? So let's try some other things with it. Let's go here and see with this one. So x cubed plus 4x squared minus 6x minus 24. That's the problem we just had. And I'm going to see if, my possibilities were plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Those are all my possibilities. I'm going to try -4. Okay, I'm going to try -4, see if that works. So I put my things down. I put 1 for -6, -24, right? I'm doing my synthetic division. I'm seeing if -4 works because I know it can only be these possibilities if it works. Drop it like it's hot, right? 1 times negative 4 is negative 4. Whoosh. 0, negative 4 times 0 is 0. Bring the negative 6 down. Negative 4 times negative 6 is 24. And the remainder of 0. And you're like, yes, it did work. It did work. It did work. And again, we know that if negative 4 works, then x plus 4 is a factor. And this tells me what's left over, which is x squared minus 6. Good deal? Now, here's the thing. This doesn't have rational factors. It's not up there. 6 is not one of them, because if I plug 6 into here, that's 36 minus 6. That's not 0. So we know that this one happens to have two irrational factors, negative root 6 and positive root 6. Those will not show up in our rational factors possibilities. Okay? However, we can still determine whether or not my cubic does this, and there's only one, or my cubic does this, where there's one rational, and two of them could be irrationals by doing something else. Okay, so this something else is called finding, there we go, upper and lower bounds. Upper and lower bounds. Okay? So, we're going to start with what are all the rational zeros? So my rational zeros for 36 are plus or minus 1, 2, 3, 4, right? 6 goes in evenly, 9 goes in evenly, 12 goes in evenly, 18 goes in evenly, and 36 goes in evenly. Pretty sure those are all my possibilities. So what I'm going to do right now is I'm going to check. I'm going to check the number 9. I'm going to check a positive 9 to see if that actually works. Okay, so what do? 1, negative 6, negative 7, 36, and 36. Okay? Do the math. 1, 9, 3, 27, 20, 180, 216, big number, not 0. Okay, I don't care anymore. Once the numbers start getting so big that you know you can't get it, you don't have to worry about it. Poof, you can ignore that. Good deal. So unfortunately, let me go ahead and write them all. Negative 1, 2, 3, 4, 6, 9, 12, 18, and 36. Out of all of these possibilities, I just determined that 9 doesn't work. Suck. That means that I still have all of these other things to still possibly check. Oh, that's a lot. Unless this thing, these upper and lower bounds, tell me something else. So here's the deal. I checked a positive number. All of these numbers are positive numbers, or non-negative numbers. Okay, got it? Non-negative numbers, which means that we could have zeros in there too. That's still okay. All of these are non-negative numbers, which means that if my parabola was graphed, wherever 9 is, if all of these are non-negative numbers, that means it will never hit the x-axis again beyond 9. Okay? Means if it's going to cross it, it's got to cross it in these spots here. How does that help me? Well, if it never crosses here, then we know it doesn't cross at 12. If it never crosses any place here, we know it doesn't cross at 18. If we never touches any place here, we know it doesn't cross at 36. And now, by checking one of these things and realizing that it's an upper bound, because they're all non-negative, I get to get rid of all 4 of those things. Is that okay? Now, I can't get rid of 6. I can't get rid of 4, 3, 2, or 1. Something still could happen in here. Good deal? Well, I just don't know. So now what I'm going to do is I'm going to pick another one. Just randomly pick another one. And let's go ahead and pick 2, positive 2. So what do? I do 1, negative 6, negative 7, 36, and 36. And bring it down 1, 2, negative 4, negative 8, negative 15, and then negative 30, and then 6, and then 12, and then 48. Good deal. So question, are all of those non-negative numbers? And the answer to this is no. So even though I know 2 doesn't work, that means, because these aren't all there, this 2 can't be an upper bound, so something has to happen in this 3, 4, 6 range. Make sense? Again, I still don't know which one it is, so I try another one. I'm going to go ahead and try, let's try 4. Let's try 4. I know you're thinking, dang, that's a lot of work. Yep, it's a lot of work. Sometimes I'll give this to you in groups of 2 or 3 people, and you can try stuff on your own. That's what you'll get from the in-class stuff. So 1, negative 6, negative 7, 36 and 36. Here we go. 1, 4, negative 2, negative 8, negative 15. 4 times negative 15 is negative 60. Negative 60, that's negative 24. There's a not 0. Crud. So 4 doesn't work, but 6 is still out there, right? Because that's not an upper bound. They're not all negative. Oh my gosh, let's try this one. And put that down. So now we're going to go with the 6. Try the 6. 1, negative 6, negative 7, 36 and 36. Here we go. Bring it down. 1 times 6 is 6. Negative 6 and 6 is 0. 0. Negative 7. 6 times negative 7 is negative 42. What is that? Negative 6. 6 times negative 6 is negative 36. And look at that. Remainder of 0. Remainder of 0. So 6 works. 6 works. 6 works. Look, we said it was going to work. It wasn't an upper bound. There still had to be something there. So that means my factors, I've now determined that x plus 6 is a factor, yes or no? Remember, if I'm trying 6, 6 is a 0, but x minus 6 is actually a factor. Okay, that's the factor. Zeros come from these things. But when we're looking at what goes, it's divisible by, it's the opposite of that. Now, I can circle the 6. I know there's no other rational numbers above it. I'm not saying that 3 doesn't work. 3 still might work. However, guess what? Because I got something to work, here's how this goes. I don't have to do this big polynomial anymore, right? I've now divided it by x minus 6. And I have a new polynomial, which is right here. So my new thing, because I was able to reduce it, able to divide it, I'm now looking at, right, this is my constant, right? So this is x cubed plus 0x squared minus 7x minus 6. And this has a whole bunch of different rational zeros, right? So now I have plus or minus 1, 2, 3, and 6. So let's do the positives there and the negatives here. 1, 2, 3, and 6. Which means if I come up to here, what can I get rid of? I can get rid of 4, 9, 12, 18, and 36. Because I've just reduced my polynomial. I know that these are my only possibilities left. Okay, so let's pick one. Let's pick one. Well, this time I'm not going to pick to see if something's an upper bound. I'm going to pick to see if something's a lower bound. So upper bounds, I can only use positive numbers to check. Lower bounds, I have to use negative numbers to check. So I'm going to try negative 2. So put that in my thing. 1, 0, negative 7, negative 6. Good. 1, negative 2, negative 2, 4, negative 3, 6, remainder of 0. Hey, that worked. If that worked, now I know, since negative 2 was a 0, then x plus 2 is a factor, and my new polynomial that's left is x squared minus 2x minus 3. Maybe I can factor that one on my own. If I can't factor that on my own, I can complete the square to solve it, or I can use the quadratic formula to solve it, whether or not they're rational or irrational. But since this is a negative 3, right, negative 3, I'm going to check it, and I think this might be x minus 3 and x plus 1. That times that does equal that. So those are my other factors, x minus 3 and x plus 1, which means, I'm going to go right here, the places that this has to cross the x-axis is at negative 2 from this one, at positive 3 from this one, at positive 6 from this one, and at negative 1 from this one. Okay? That's how it all matches up. Okay, now, I know I didn't go back to this, this thing right here, right? But I want to point out some stuff for you. I know that it hits at negative 2, negative 1, 3, and 6. But I didn't tell you about this lower bound thing. I still got to check the lower bound. So we're going to go right here in my notes. And here's a lower bound check for this one. Now, it's really tough because my things were at negative 1 and negative 2. So, the question is, do lower bounds still work if I choose numbers in between there? And I know this looks a little sketchy, but we're going to make it work. We're going to do this, okay? I'm going to choose negative a half, negative 1/2, with my numbers down here. I can even do my original one. I can do that, right? 1, negative 6, negative 7, 36, and 36. I know the math is going to be hard, but I believe in you guys. So bring the 1 down. 1 times negative a half is negative a half, right? And negative 6.5 times negative a half is positive 3.25, and that's negative 4.75, and that's all I need to check right now, okay? So here's my thing. In order for something to be a lower bound, which means that there would be nothing to the left of that spot, and again, we're trying negative 1/2. In order for something to be a lower bound, these things would have to alternate between non-negative and non-positive. So what does that mean? What does that mean, alternating between non-negative and non-positive? 3, negative 4, 6, 8, 2. Do these alternate between non-negative and non-positive? Well, this one's not negative. Check. This one's not positive. Check. This one's not negative. Check. This one, oh, this one is positive. So this doesn't alternate between non-negative and non-positive. However, now it does alternate between not negative, not positive, not negative, not positive, not negative, right? This would be a sequence of numbers that would guarantee that that's a lower bound. And I know some of you are like screaming into the mic going, Mr. Bells, can't I just say it's positive, negative, positive, negative, positive, or negative, positive, negative, positive, negative? No. Here's why. If my numbers were 4, 0, 3, negative 2, 8, do those alternate between positives and negatives? And the answer is no, they don't alternate between positives and negatives. However, this one is non-negative, correct? 0 is not positive because it's neutral, not negative, not positive, not negative. This also would guarantee a lower bound. Okay? So, one more time. If it matches these alternating non-negative, non-positive, non-positive, non-negative, that means that that number is a lower bound, whatever you checked, which means it can't cross the x-axis any place to the left of that number, which means you could get rid of a whole bunch of these possibilities when you're doing it. Okay? So, still back to this, and I want you to see this original polynomial problem here, clear. Again, this is why you need to be in class, if you can be in class, because getting all the stuff that I put in these last two videos on your own sucks. So I'm going to type it in now. We're going to show tech. Remember, I've done everything without tech so far. X to the fourth minus 6x cubed minus 7x squared plus 36x plus 36. Okay? That's where we're at right now. Zoom. Oh, before I hit zoom 6, right? According to us, again, we did this all without technology. According to us, it should hit, right? Those are all our factors, so it should hit at -2, -1, 3, and 6. Are you kidding me? Can I do this, right? Does it really do this? Graph. -2, -1, 3, and 6. Let me blow my window up a little bit so you can see it even more. I don't know how far I have to go. I'm going to do this. Let's see if that shows it to me a little better. Pretty close. Window, I'll make that Y scale 50 so it's not showing up in there. I go a little deeper here, -80, and a little taller here, 80. I do graph. Oh, so close. Window, Y min, -90. And now you can see that is my quartic function, my degree 4 polynomial. And yes, it hits there, 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 and there. Now, how do I know easier on my graph to find those zeros? Well, if they're rational, right, they hit at whole numbers or at fractions of whole numbers. Second function, table setup, I'm going to start it at -5, and I'm going to have it go up by 1. And you can see a 0, a 0, a 0, and a 0. Again, much easier to do with technology to be able to check these things. Much easier to be able to do that with technology. However, I think there's something cool about being able to use your brain to be able to say, oh my gosh, look at this. In order to find those ones without technology, that's pretty cool. Now, I had to do, I don't know, several hundred computations, but you're going to get better and better at it. So what you're going to do is you're going to try this one right now. Try this one on your own. See what you got. I know that's a lot of factors to think about. A lot of factors to think about. I'll write them down with you right now, and you could pause the video at any time and stop and try stuff on your own. So plus or minus 1, 2, 3. 6 goes evenly into there. Yeah, 6 goes in. 9 goes in. Man, 15 goes in. 20 doesn't go in evenly. 30 goes in evenly. 45 goes in evenly. And 90 goes in evenly. That's a lot of things to check. That's a lot. But remember, right? As soon as we find 1, that's all we got to do is find 1. When we reduce this cubic, we can reduce it to a quadratic. And any quadratic can be solved by completing the square or factoring. I don't have to keep doing this process. So all I got to do is find 1. Next, if I don't find 1, like this one right over here, good deal. It also, let me do this one right over here, since those were all positive. Even though I didn't find 9, I also got to get rid of 12, 18, and 36 because of my upper bound rule. Good? Okay, so here we go. Oh no, I'm gonna try 6. Let's try 6. 1, 12, 11, -90. Trying 6. Bring it down. 1, 6, 6, 18, 6, 18. Whoa. That's big, right? Big, 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 huge. So big positive, ginormous positive, even with negative 90, right? You're doing 6 times like 70 something, that's 400 plus. All of those are positive, which means 6 is an upper bound, and 1, 2, 3, 6, 9, 15, 30, 45, 90. Those are all the negative ones, right? All the negative possibilities. So 6 doesn't work, 9, 15, 30, 45, 90. Look at all those ones we just got to get rid of. Awesome. Okay, so then I try something else, and I try like 2, and see if 2 works, or try 3, see if 3 works, I don't know. So 1, 12, 11, negative 90. Let's go ahead and try 2. 1, 2, 14, 28, 39, 60, 78, negative 12. Oh, they're not all positive. So that means if 2 doesn't work, there's still got to be something to the right of it. So let's try 3. 1, 12, 11, negative 90. Oh, oof. 1, 3, 15, 45, 56. 3 times 56 is 168. Positive. Oh, 3 is an upper bound. So, what did we just learn? What did we just learn? That means that there has to be something between 2 and 3 that is irrational. Irrational, or my math was bad. Okay? So, because I ran out of space on this piece of paper, I'm going to go right here, and I'm going to show you on the calculator that this is all working well for us. Clear, I'm going to put that in. X cubed plus 12x squared plus 11x minus 90, and zoom 6. And look at that. Right there between 2 and 3 it goes through, but it doesn't go through at a very pretty number, does it? It looks like it goes through at a pretty number here, yeah? That looks like it might be negative 4. I'll do a quick check on my thing. Started at negative 10. My graph, oops, sorry, it looks like it started at 10. Let's go to negative 10. Look at that. Oh, negative 10 has a 0. Negative 4 didn't have a 0, but negative 10 does. Negative 10 does. So let's go to here and show that work right now in this spot. So let's try negative 10. We just showed on the calculator it's going to work, right? 1, 12, 11, negative 90. And here we go. 1, negative 10, 2, negative 20, negative 9, 90, remainder of 0. Yay! It was a remainder of 0. Dun, 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 dun. So x plus 10 is a factor, and x equals negative 10 is a 0. But more importantly, this is what you needed to find out, that x squared plus 2x minus 9 is what's left over. Now, question, is it factorable? No, it's not factorable. We just showed that on the calculator, right? On my graph, it went through at an irrational number, a yucky thing. But there's real ones, right? Way over here. Window, x min, negative 30, negative, so negative 20. You can see it goes through, right? But those two things are going to be irrational. Well, how do I find that? We had two possibilities, right? We had the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a, or we had these completing the square process. X squared plus 2x equals 9, right? I'm trying to find the zeros of this function, so I move this over. This is not putting it in vertex form where we keep it on the same side. This is solving the equation using completing the square. Half of 2 is 1. Put it in my little square box, square it. Plus 1 to this side, I plus 1 to this side. This factors into x plus 1 squared equals 10. Then what I do, I square root both sides, and x plus 1 equals plus or minus the square root of 10. X equals negative 1 plus the square root of 10, and negative 1 minus the square root of 10. These are approximately, on my calculator, let's do this right here. Clear, negative 1 plus 10 raised to the 0.5, 2.16. There's the number I said was going to be between 2 and 3. Negative 1 minus 10 raised to the 0.5. Again, that's square rooting, right? I didn't do square rooting. I didn't raise it to it. Negative 1 minus 10 raised to the 0.5. Oops, that's a lot better. Negative 4.16. Negative 4.16. Let's check on my calculator. Graph it. Y equals. Let's set it equal to 0. Intersection points here and here. Second trace, number 5. Enter, enter, enter. Look at that. Negative 4.16. That's what I got from completing the square. Right? Over here. Second trace, number 5. Move my cursor over there. Enter, enter, enter. 2.16. 2.16. However, you can see I did all of this without any technology. Okay? Again, big picture stuff, big picture. This is supposed to help offset what we did in class. Okay, now, last things. Nope, I'll put it on a different video. If you're still watching, you're awesome. I know this isn't easy. There's a lot of stuff to it. Stay with it. Stay with it. Like I said, everything we do in this class, the more you can do, the more you can handle, the better off you're going to be. And if you've watched this video and we've done it in class, you're going to rock star this next challenge thing that we have in this class. Okay? I'm tired of holding the camera right there. We'll talk to you later. Bye.